All right, for this problem, you have to draw all possible elimination products. All right, so we have this alkyl halide. The base is sodium ethoxide in ethanol. That's a solvent. All right. Since this is an E2, so look for a beta hydrogen. This is alpha position, and these are beta positions. And notice that these two are the same beta position. All right. So basically, my point is there are two different beta positions on here that should lead to two products. Okay. All right. The first beta position. All right. Let's say I take so these two carbon are the same things. Take one hydrogen from any of this. All right. Do elimination, and you should get that the first product. And the other one, so the inside one, so there's another beta hydrogen in here. So beta hydrogen elimination, and you get another one there. Okay. So two products here. Which one is a major product? Well, let's take a look at who's more, which process is faster. Can you think of that? Should be this one, right? If you still remember, this is more stable alkene, right? More stable alkene, which means that the transition state gonna be more stable or lower activation energy than the first one, right? We have trisub, disub. This guy more stable alkene. The transition state is more stable, lower activation energy. Reaction goes faster. At the bottom right here. All right. So we have a major product here and a minor product there. All right. So you can get multiple products in an E2 reaction. All right. Now we're going to talk about the regioselectivity of an E2. Regios mean region and selectivity. So an E2 is really picky on the region that the reaction will happen. Right. Where to do elimination. For this one we just saw earlier. So the more substitute alkene is a major product. We call it Zaitsev product, which is we have Alexander. I don't know how to say his name. Zaitsev. He's a Russian chemist working with a lot of elimination reaction, and he found out that the product distribution favors the more substitute alkene, right? Because it's more stable. The transit activation energy is lower. Reaction go faster, so you get more of this, right? However, if he switches base to a different type, right? This is third butoxide, much bigger than a sodium ethoxide, much bigger. The product distribution favor the least substitute alkene. We call Hofmann product. Okay, you don't have to memorize the name, but there's one is the major, one is the minor. Basically, that's what you need to be able to indicate. Okay, so use a small base, go to Zaitsev, the big base, go to Hofmann. But how come though? Let's take a look more with the product distribution some more. We have a small base, we have isopropyl group, we have there's a third butyl group, and we have like a 7 carbon. It's really big there, all right? The small base favor the Zaitsev, the big bulky base, highly sterically hindered, favor the Hofmann, all right? And here's the reason for it. All right, this is what you should know. All right, for the small base, this is small. They can go anywhere. Let's take a look at the whole molecule here. I show the full structures. All right, so high sterically hindered around this proton and that proton. For a small base, it's small. They can go anywhere. Right? It does know that the elimination of this proton, the inside one, produce more stable alkene, which means that this process is go faster. Right, that's why we get Zaitsev product rather than Hofmann product. Favor the Zaitsev one. All right, but the big bulky base. I'll take a look. Big bulky base doesn't have this option though. He does know that the inside one gonna give more stable alkene, but he cannot get inside. too strictly hindered. Right, he can't really get. It's not accessible compared to the outside one. So the E2 outside beat the E2 from inside. Right, so that's why the big base favor the Hofmann product because it's easier to grab that proton. All right, the rate of the E2 inside the molecule is real slow, much slower than the outside. Okay, so we have the major product there. All right, so here's how you select what base to use based on what product you want to get. Do you want the more substitute alkene one, or you want the least substitute alkene? All right. If you want the more substitute alkene, you take a small base, sodium hydride, sodium methoxide, sodium hydroxide, sodium ethoxide. These are like alcohol and water, and sodium hydride. You're going to see it quite often here. The big base, this one, I'm gonna go favor the Hofmann product, the less substitute alkene. The major one that you're gonna see, potassium terbutoxide, you're gonna see this very often. And an LDA, this one you're gonna see up to or go to, if you take it, lithium diisopropylamine, LDA. Sometimes you're gonna see TEA, triethylamine, so T, E, and A. Diisopropylethylamine also. Common one, but the top two you probably want to be familiar with the most. Okay, this one I'm sure you're familiar with all this: sodium methoxide, ethoxide, hydroxide, and then hydride. All right, let's do this together on the next video.